Hi, I'm Miss Sheridan. I'm here today to talk to you about microbiology. I am the microbiology teacher here at Cheltenham, and I have been doing this for the past 28 years, and it's been a whole lot of fun. This year will be a little bit different because we're doing it virtually, at least for the first half of the year. So I want to go over what you can expect from me and what you can expect that your child will be learning while they're in microbiology. So, welcome to microbiology. The picture here is a picture of me in my classroom, and hopefully, we will get back there soon. So, I'm just going to move on through these slides here. So, the course framework for microbiology, and I have a microscope here because it involves lots of microscopic work, and I like to spend most of my time in the lab with the students. So the two essential components are science practices and course content. I would put laboratory work as my number one focus, and the content obviously follows with that. So to that end, I will do the best that I can trying to get lab content in there this year. I have asked for some special software, and hopefully that will be available to us soon. Some of the units that I cover with the students. We just finished covering the importance of hand washing, and we tied that in with the COVID pandemic that's now happening that we're involved in, and we know how important hand washing is. I also tied it back to the importance of hand washing with healthcare workers and people who work in facilities that treat patients. We went back and we looked at history of hand washing. We talked about Ignaz Semmelweis, who was a very important person, a doctor who was important in implementing hand washing protocols for the delivery of babies and the prevention of death from sepsis, basically, in women who had babies delivered by doctors. And there was a higher rate of infection in the mothers who were, helped by doctors rather than midwives. We also talked about some public health issues surrounding typhoid Mary and her being put in isolation on North Brother Island, and similar things with isolation and COVID-19 and, the rights of people and who makes these decisions and things like that. So we'll get into a lot of public health issues. That's just like a little bit of kind of what we do. Generally, for the first part of the year, I cover bacteriology, and then I do viruses. We do epidemiology and public health. Like I said, we kind of tie that in throughout the year. We do a whole unit on food microbiology and foodborne illnesses, and usually tied in with that is a kind of fun activity where the kids actually have to investigate an outbreak of food poisoning that happened amongst the staff at Cheltenham High School. Obviously, it's a fake outbreak, but every year I change it up, and I have a lot of teachers that volunteer to participate, and they really have a lot of fun, and the kids have a lot of fun too. And part of this mission is that they have to act as epidemiologists and go out and interview the staff members, see where they were, what did they eat, who did they meet, and they, in the end, as a group project, they have to come up with the cause of the outbreak, the source of the outbreak, who was sick, who wasn't, what they think what they think that the people could have done to prevent it, and they present their report on that. And they usually have a really good time. And like I said, the staff at the high school really enjoy it too, because it gives them a chance to get to meet other students that they don't teach. And it's just a whole lot of fun. People asking about their poop and their vomit and all this other stuff. So we have a really good time doing that. How we'll do it this year, not really sure, but I'll do my best to try and make that work. We may have to do kind of virtual interviews or something. We'll see. Maybe we'll be back in school by then. We'll talk about control of microorganisms. I will do a unit on immunology. I will also talk about parasitology, and we'll do some genetics, some biotechnology, some genetic engineering. We'll talk about that. We'll talk a lot about testing. And as you can see in this picture here, it's a group of my students working on a project. This is a project I did a few years ago with a professor up at Tufts University. And we were investigating the prevalence of antibiotic-resistant bacteria in soil. And the data that we collected, we actually shared on a national scale all of our data that went into a database where other colleges were actually collecting data, doing the same thing that we were doing and contributing to information on that project. So this is an introductory college level course. Students do a lot of bacteriology in the lab when we're at school. Hopefully we will get back there and we'll get everybody in the lab. If not, we'll be doing things virtually, and hopefully it will still be interesting and a lot of fun, because I think that doing things is a whole lot more fun than just reading about them. And that is my goal, to make everybody have a good time and learn at the same time. Okay, so a textbook. I'm not really a book person. I don't, assign the book to read the book, do the book questions, do that kind of thing. I generally like to present the topics that I feel need to be covered, and no book actually covers it in the exact way that any one of us as instructors would. But we do have a book as a reference. It's located on openstacks.com, and they will have a link to this. You can go there. You can use the book for free. Anybody can go there. And in fact, if your child needs a textbook for another course or needs a reference, just Google openstacks.com. It's run by Rice University down in Texas, and they have books on every subject. So AP Bio, AP Psych, statistics, microbiology, history, you name it, they've got it. And they can go on there and they can look through all the chapters of the book. They can download a PDF of the entire book. They can use the book online, but they don't have to pay for it. So there's no reason to pay for a textbook. And it is a college level textbook. So this is the book that we will be using as a reference. The class format. For my instructional model right now, we're using a virtual instructional model. We have synchronous lessons and we have asynchronous lessons. Like I said, the textbook as a reference will be OpenStacks, and it will be microbiology. They will have lab activities and projects. Even if we can't do the same lab activity in class, they will still have virtual labs and projects. Hopefully we'll get the Labster lab software up and running soon. We're trying to get a site license for that now. Once we do that, that'll give us a much better opportunity to get some of those lab activities going here. Everything will be on Canvas, and students will be using the Google Drive to submit all their documents and their spreadsheets or anything like that. They will upload everything that they hand in to me on Canvas in the modules under the assignment. As far as test quizzes, those kinds of things go, they will be multiple choice. They can be free response. And there'll probably be more short tests than long ones. Okay. They will be timed and they will be online. They will go through Canvas to do this. And when they go on there, they'll have a procedure that they have to follow. And most likely we will do this during our synchronous time. And I don't want to use up our whole synchronous time to do this. So that's how we'll do it. If anybody has a 504 at IEP, don't worry about that. We can accommodate time with these tests and quizzes. So if that's an issue, I'm certainly aware of those things. If ever you have any questions about any of these things, please reach out to me by my email, which I'll give you at the end of this presentation. So science practices, things that they're going to learn how to do. They will learn how to prepare a gram stain. So right here, you can see in this picture here, I have a plate of bacteria that's been streaked. And here is a slide, and a student is preparing a gram stain to observe under the microscope. up here, I just put this up. We do some kind of cool fun things too. After we finish our bacteriology unit, I usually will give the students a variety of bacteria that produce different pigments. And we have a bacteria art contest. And I'll have everybody get a petri dish with agar on it, and I have them make their own designs on a petri dish. And it's kind of cool, some of the things that they've come up with. They do this at a higher level in the microbiology community. There's a lot of people who submit their work. There's some excellent work out there with this. I got a grant for 3D printers last year to use with microbiology. We will be able to use these. The grant enabled me to buy 2 new Prusa printers. This is one of them here. I put them together, built them this past summer. So they are ready. They're here in my dining room, ready to work. So if we can't get back into the building, the kids can still use some software called Tinkercad and design different models. Last year, they designed models of viruses, and I can print them out for them and then deliver them to their house or have them sent to them so that they can get them. These 3D printers down here are Dremel 3D printers. I also have one of those. So I have 3 Prusas and a Dremel available to use. So hopefully we will be using the 3D printers this year with some of our projects. So that's kind of exciting, and the kids really, really like using them. They have a lot of fun. For grading, my grading policy is basically everything's worth points. So students are given, if something's worth 50 points and you earn 50 points, it's 50 out of 50, that's 100%. But my grades will be based on total points. So they will get points for everything that they do. And at the end of the marking period, basically, it's the number of points they earn divided by the total number of possible points. So things that get graded, obviously unit tests, free response questions, quizzes, the projects, which would be labs or inquiry-based activities. So there could be virtual labs, there could be group projects. Like I said, they could be making things on the 3D printer for part of a project. They could have where they're analyzing some work for like the food poisoning project. That would all come in under projects and lab inquiries. For the synchronous part of our learning, when I'm giving notes or I have them do different things together, I expect that they will be on task during synchronous classes with their cameras on. There are times where, students turn their cameras off, but when I call on them to answer questions, especially, I expect them to have their cameras on and to respond to me. Students that don't respond to me and don't have their cameras on, it's really unclear to me whether they're actually paying attention or participating. They could have just turned the computer on and walked away. And I know we all have to get up and go places. So if you turn your camera off and you had to go to the restroom or something like that, I totally understand. But I will, during all synchronous classes, try and ask questions and get people to participate through, everyone in the class. I usually try to get everybody to speak at least one time. So they'll need to respond to questions. They'll need to collaborate on class activities. So if I give them, let's say, a Jamboard that's posted on the screen, and I ask them to put a sticky note up with their opinion or what their answer is, or put something in the chat, that's what I'm expecting here for class participation. I also utilize the Edpuzzle platform. I use this mostly for notes and then also for some videos that I might want to show. It's not possible to show a video in class very well. What I'm having is a lot of lagging on the student side in watching the videos. So I try to show them the videos, but if that's not possible, I will send them the link. And a lot of the videos that I have to show them, whether it's how to do a technique in the lab or whether it's to see something that I'm presenting, like we watched a movie about Typhoid Mary. That will either be through an Edpuzzle or a posted video that's on Canvas. They will have readings from journals or other places, or maybe even the newspaper or something like that, and written assignments. So it's a variety of things throughout the the semester that will be utilized to get their grade. So if they're not good at like a test, there's always a project or a lab or an ed puzzle. So I always tell the students, make sure you do your best on all of these things here, the projects, being on task, answering questions, collaborating with others, doing your ed puzzles, doing the readings and the written assignments, because then if you're not a good test taker, it's not going to affect you that much. The other thing with ed puzzles, I really want them to understand the material that's asked of them in the ed puzzles. So I let them retake the ed puzzles as many times as they want before the due date. Okay. So that's an important thing. So if they got a 50% on an ed puzzle, it's okay. If they send me an email, hey, Miss Sheridan, could you reset the ed puzzle on whatever it is? And I will reset it for them and they can redo it until the due date. But I also tell them, I do go to bed at some point in the night, so don't wait till, the last hour to ask for that reset. I'm always here to help. I have office hours. During those office hours, I am available on Google Meet. Students can hop on and hop off anytime they want during those office hours. They can also make appointments with me. Tips that I give them to study for tests and quizzes. I think flashcards are very helpful. Somebody else may not think they're helpful, but I do. So, these are the list of things that are just suggestions. Maybe they can make a group study guide or a, study group where if they have friends that are taking the class and they can get together virtually and study with one another. Rewriting notes, outlining the notes, taking the PowerPoints that I will post on Canvas with all the notes, going through them, writing down what you don't understand, hopping onto a Google Meet, asking a question. If there's something you don't understand, maybe look it up in the OpenStax textbook and see if you can understand it better there. If not, again, jump on Google Meet or bring your questions to class. Somebody else probably has the same exact questions. Look online for practice quizzes and tests. They're out there. There's lots of Quizlets that are already made up on a lot of these topics. You can find them. Complete all the assignments in the study guides, because if you do that, 9 times out of 10, they're going to do well on the quizzes and tests, because I'm not looking to trick anybody. So this is probably the biggest thing right here. There will be practice Kahoots. And again, schedule an appointment for extra help. So this is microbiology, and I hope this was helpful for you. I look forward to working with all of your students. And if you need me, please don't hesitate to email. Goodbye.